Hi everyone, I've got an off-grid cabin with a 12-volt battery bank supplied from 500 watts of solar panels. When the battery bank's full, I thought, how do I use the solar panel power to heat a water heater or to heat a room heater? So I thought about this for a while and I came up with the idea of using the same technology used to drive a variable speed on a motor. This is pulse width modulation. So here we have my pulse width modulation unit that basically takes power when the voltage of the battery is above 13 volts and uses that to supply any load you like, water heater, air heater, whatever you want. So essentially what we've got here is incoming power supply here from the battery bank. We then feed it through this integrated circuit here and we supply this IC with the reference voltage, and this IC, this operation amplifier, gets the difference of these two signals and supplies it to this integrated circuit here, which is the DRV103 pulse width modulation unit. It in turn then switches on and off these power MOSFETs at the back here, which then puts power to the loads. So let's have a look at it at the moment. So currently we've got 13.04 volts on the battery and the output is currently 2.3 volts, and you can hear a slight noise here because this fan here, which is my load at the moment, is going round. So 13.05 volts, we've got 2 volts out. So basically it's chopping this voltage and stopping some of it and only allowing an average of 2 volts to go through. Now as we put the solar panels on, and I'll simulate this by charging my battery, you'll see the voltage will increase on the battery, and you'll see also the output voltage also increases. So let's just do that now. Here we go, it's on. The battery voltage is now climbing up to 14.4 and climbing up some more, and you'll see the output is also mirroring that. It's now 14.64 volts and so on. And let's say the cloud came over and the solar panel switched off. There's no now power going to the battery. The battery then starts to decline in voltage. And you'll see that the output has also declined in voltage now to 9.8 volts. And as this 13.47 voltage on the battery declines, so will the output. And eventually at 13 volts, there'll be no output. So this is the circuit. And the main thing is, little resistor here allows you to adjust at what voltage the system shuts off. I've got it at 13 volts, but it could be 13.4, it could be 12.8, whatever value you like. And I made this up from a 12 volt to 240 volt inverter. I took it apart, removed the bits that I didn't want, and kept the rest. So I kept the input power terminals, I kept the cooling fan, I kept the USB ports and its integrated circuit for supplying the 5 volts to it, I kept the on-off switch, and I kept the LEDs that give an indication of the power on and off and so on. And then I made up this new circuit here, added it into the whole system. I guess there's about 40 pounds of parts in this, including the box. And I've included the circuit on my website and I'll show you the link below. But in essence, it seems to work pretty well, and it's able to deal with over 500 watts of power in a very small unit. It's a nice way of just using the excess power without banging the loads on and off all the time. It just takes a small amount of load when a small amount of power is available. If a lot of power is available, it'll take a large load and dump the whole of the solar panel power to wherever you want it. Thanks for watching. Bye for now.